Today on TestCase TV, we're going to discuss potentiometers and how that relates into what is called a voltage divider. We're going to look at how a potentiometer affects both resistance itself as like a variable resistor, and we're going to look at how the potentiometer, when dialed in, also affects the voltage on any line. And that's going to lead into projects later on where we're actually reading in the rotation data of a pot, which is short for potentiometer. So let's get started. Right now I have a 10K potentiometer, says so right here. So that means that from lead number 1 all the way up to lead number 3, we have a resistance of about 10,000 ohms. And that's going to be a constant. But this middle lead, number 2, is actually going to vary in its resistance because there's components inside attached to this middle piece that guide over the semiconductor material between 1 and 3. First, we're going to connect the multimeter to lead 1 and 3 to confirm the 10K resistance. And then we're going to switch one of our leads to the middle and then see the rate of change and what I mean by the variable resistor, because that's essentially what this is. I'm going to connect my red line for my multimeter to this alligator clip, which is connected to my lead 3 on the potentiometer. Connect my black one to the green. So now green is going here, red is going here, and I should see, yep, 9.9 kilo ohm, 9.91. So it's close to a 10K. And we had discussed earlier in resistors usually have like a 5 or 10% deviation. That's kind of going to be true for a lot of these components. So when I say that even though we can do all the math in the world we want to get everything exact, there's slight deviation physically in every component you're going to get. Just be aware of that. It's not something to stop you from progressing. Now, if I change or I turn this knob, which is what gives us the variable factor of this device, there shouldn't be any change right there. So I don't even have to look at it because I know it's not going to change. But if I switch one of my leads, so the red line over here, I'm going to switch it so it's actually connected to lead number 2. Now, what's happening is this wire is coming in and it's being attached to this knob underneath this fiberglass front piece. And behind that, it has kind of like a spring built in that's gliding on top of the surface that goes around. So as I turn closer towards this guy, my resistance will actually fall. It gets lower because the amount of material that the electricity has to go through is much, much smaller between this point and this point when the actual contact is almost touching. Same thought process goes for the other side. So as I go farther away from here, my resistance is going to change as I turn a little more, turn a little more, all the way up to the top. And when I do that, I should be close to my 9.9 kilo ohm resistance. There we go. So that is how this works as far as getting your reads for a resistor. So it's really cool because with LEDs, if we don't know what size of an LED we want, and as long as we're within our safe range to not burn the LED out, say we want a resistor to limit how bright the LED actually is, we can hook one of these up just to 2 leads, kind of like how this is working, and dial it until the LED is the brightness we want for an installation. Super handy, because then we can take our meter, just like this is connected, and get the exact range of LED we need to permanently install it without having this giant piece in our wearable tech or our circuits or anything else we want to build. Now, let's play around with this in regards to voltage, because when we start dealing with the Arduino and other microcontrollers and taking in the voltage ranges to give us data, we're actually measuring a voltage range. If I connect a 9-volt battery to this from here to here, just like I would put this on my negative and number 3 on my positive, then between those I should have a 9-volt range because it's connected to those two leads. But what I want to see is what happens in the middle since we have the resistance changing. So I have my 9-volt battery. I am now going to connect what I have here on my ground side to the ground side of my 9-volt, which if we look here, this side's positive, and that's going to be my negative. Now that we have our battery connected, this is with the negative lead through the black wire, goes all the way to both my multimeter and the lead, the pin 1 on my potentiometer, right here. And the positive side of the battery is connected to my pin 3 of the potentiometer. I can now monitor a change in voltage through my multimeter. And my multimeter I've just set to volts, as we've looked at in the multimeter video. I can now see what's coming out as far as potential voltage on my middle lead, my pin 2. All right. So with that, let's go all the way towards the ground. All right. So I'll turn it left, and when I do that, my voltage is much closer to the ground value. Right. So I should have, 0 millivolts. Basically, what's happening is the contact is so close to the ground that when electricity comes in and it goes through all this resistance, when it gets to the 1 pin and the 2 pin, since they're so close together, there's almost no difference as to which one to prefer, which path is easier for the electricity, because electricity likes to go path of least resistance. All right, I'm going to go all the way towards the right, and as I do that, this will change, increase, 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 all the way up to where it stops, and I should be getting the actual voltage of 3 because it is pretty much touching and giving me the reading of the battery itself. So that's a whole range that I can swipe across with my potentiometer dial. Now what's actually happening and what makes this really cool is I'll go closer towards, I'm going to say, 75%? Just by feel. So right now the inside of this is touching somewhere around here on my potentiometer. What's actually happening inside is because since we're going through a semi-conductive material throughout the entire arc, even though we know we can measure resistance on any 2 pins over here, there's also resistance on 2 pins over there. So what's happening is in this range of 10 kilo ohm resistance, as I wipe anywhere in between, well, there's still material here and still material here, so it's kind of a factor as to where in position is depending on what's easier for electricity to come out. And that's why we have the variance of what the voltage is being read, because there's essentially a voltage divider, and depending on the value of the 2 resistors, that's what's going to give us our inevitable output. We've been able to observe the resistance change as we dial the potentiometer, and we've also been able to see the after effects of the resistance change with voltage, because ultimately that's what we're going to start reading with our projects in the Arduino and everything else later on. So let's have some fun and see what's inside this thing, because ultimately this is how I've learned everything I know right now, is taking things apart, catching them on fire, seeing how they work. Let's clear the table, we'll isolate the pot by itself, and we'll start taking it apart. So we're going to do a part called Pot or Not. This is a pot, that's a pot, that's a pot, that's a not. That's definitely not. That could be a pot. That's a pot, but not the right kind of pot. That's a pot, that's a bear. That's a pot, that's a pot, that's a pot, that's not a pot. That's, what the hell is that? Seriously. Is that 2 ducks? Maybe. That's a pot, that's a pot, that's a pot. This is surprisingly a pot.